Hello friends, this is Bharti and you are watching Learn Maths with Bharti. In the previous videos, I have explained you the trigonometric table and I explained you to how to remember the trigonometric table and we have solved some problems. And in other video, I have explained you 3 sums from the similar triangles. If you have missed those videos, please go and check it out. For that, I will put the video link in the description box below. And if you are new to my channel, please subscribe to the channel because this kind of videos I will bring to you daily to make the maths concept simpler and easier. Okay, now let's jump into the video. So friends, today we are going to learn trigonometric identities. So, suppose we have a right triangle. It is here one angle is 90 degree. Let this angle is theta. Okay. So what is an identity? Uh, do you remember any identity? Any algebraic identity? Okay, let me write here. A plus B whole square. A plus B whole square is equal to A square plus B square plus 2AB. Okay. So it is first of all it is an equation because it has one left hand side and one right hand side, LHS and RHS. And why it is called an identity? Because it is true for all the values of A and B. It is true for all the values of the variables. Okay, so it is called an identity. It is an algebraic identity. Similarly, we have 3 trigonometric identities. We have some identities in trigonometry. Those are called trigonometric identities. So let us learn what are those. Okay, here we will write some identities. First one is sine square theta plus cos square theta is equal to 1. Okay, it is an identity. So it is also an equation and it is an identity because it is true for all the values of theta. It means 0 to 90 degree. So one more identity, 1 plus tan square theta is equal to sec square theta. Sec square theta. And another one is 1 plus cot square theta is equal to cosec square theta. Cosec square theta. Okay. So these are the 3 trigonometric identities, and we will use these trigonometric identities in different ways. Suppose sin square theta plus cos square theta is equal to 1. It is an identity. It can be written as sin square theta is equal to 1 minus cos square theta. Okay. Now it can be written as like this also. Cos square theta is equal to 1 minus sin square theta. Isn't it? Okay. Similarly, the second identity, we can write it as tan square theta is equal to sec square theta minus 1. Okay. And sec square theta minus tan square theta is equal to 1. Here, 1 plus cot square theta is equal to cosec square theta. It can be written as cot square theta is equal to cosec square theta minus 1. And one more way is there, cosec square theta minus cot square theta is equal to 1. Okay. So we can use it in many ways. Now you have to remember all the relations between the trigonometric ratios. It means you should remember the reciprocals. Cosec theta. Cosec theta is equal to 1 by sin theta. It means sin theta and cosec theta are reciprocals to each other. Okay. And sec theta. Sec theta is equal to 1 by cos theta. Okay. Cot theta is equal to 1 by tan theta. And tan theta can be written as Sin theta by cos theta. Tan theta can be written as in terms of sin theta and cos theta, okay, and cot theta is equal to cos theta by sin theta. Further, you will apply all these relations, so you should remember all these, okay. Now let's move to the next slide. So friends, here we have question number 1. Let us solve it. Here the question is, express the trigonometric ratios sin A, sec A and tan A in terms of cot A. We have to express sin A, sec A and tan A in terms of cot A. Okay, so let us do it. First, using trigonometric identities, we can express any trigonometric ratio into another trigonometric ratio. Okay, so here first we will take sin A. So we have to start from sin A and we have to convert it into, we have to express it in terms of cot A. Okay, so how we will reach there? Sin to cot. Sin, okay, do you remember all the identities? The third identity, do you remember third identity? The third identity is a relation between cot and cosec. If we reach sin to cosec, then we can easily reach from cosec to cot. Okay, but you know that the reciprocal of sin A is cosec A. So we will write sin A is equal to 1 by cosec A. It's very simple. See, now we will reach to cot A. How? You know the third identity? Third identity says that 1 plus cot square A is equal to cosec square A. Do you remember? It means what? If I will take square root here, then it will become cosec theta. It means cosec theta, let us take it A. Cosec A can be written as under root 1 plus cot square A. It means 1 by cosec A can be written as under root 1 plus cot square A. Now you can see here sin A can be expressed in the terms of cot A. Okay, it is done. Now let's take another trigonometric ratio which is asked in the question. It means sec A. Okay, now we have to reach from sec A to cot A. So from sec A, we will go sec to tan, then tan to cot. Okay, sec A can be written as how? Second identity. What is the second identity? 1 by tan square A is equal to sec square A. It means under root 1 plus tan square A can be written as sec A. It means sec A can be written as under root 1 plus tan square A. Under root 1 plus tan square A. Okay. Now we have to change it. We have to go from tan to cot. So what is the reciprocal of tan? Cot. So under root 1 plus 1 by cot square A. If we take LCM, then we will get cot square A plus 1 by cot square A. But denominator, you can see here, we can write the square root separately for numerator and denominator. So cot square A plus 1 by root over cot square A. So here the square root and square is cancelled. So here cot square under root cot square A plus 1 by cot A. See, now we have only cot A. Okay, so we have converted. Okay, so we have converted here. Okay, sec A into in terms of cot A. Done. Okay, it is the answer. Now let us take another one, tan A. So tan A is equal to, we have to reach from tan to cot. Okay, what is the reciprocal of tan A? Cot A. Tan A is equal to 1 by cot A. So it's very simple. Okay, we have expressed tan A in terms of cot A. This is the answer. I hope it is clear to all of you. Let's move to the next slide. So friends, here we have question number 2. Let us read it. Prove that cosec theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. So here we have to prove it. It is also an identity. So we have to prove it using the trigonometric identities which we have learnt earlier. Okay. So here we will start solution. So we will start from LHS and try to get RHS. Okay. So here left hand side LHS is cosec theta minus cot theta whole square. Okay, actually it is looking like a minus b whole square. So many students think that here we should use a minus b whole square identity, but it will be tough for you. Okay, so what is the easy way? Whenever you see cosec and cot, or okay, sec or tan, sec, cosec, cot, tan, then you should convert it. You should express it in terms of sine and cos. It means, see, cosec theta can be written as 1 by sine theta. Okay, 1 by sine theta. Always you should try to convert it in terms of sine cos only. Whenever you see cosec, cot, sec, tan, then you try to convert it in sine cos. Cosec theta can be written as sine 1 by sine theta. Okay, minus cot theta can be written as cos theta by sine theta. Now whole square. Now see the right hand side also. We have to reach this cos terms. Okay, so here we have to take LCM here, sine theta. Now here 1 minus cos theta. Now whole square, taking LCM. Okay, now separate. Okay, 1 minus cos theta whole square by sine theta, sine square theta, sine square theta. Now we want cos theta in numerator also and cos theta in denominator also. See here, we want cos theta in numerator also and cos theta denominator also. But here we have cos theta in numerator only. In denominator cos theta is not there. But we should try to get it. How? See, 1 minus cos theta whole square. Okay, by. Now you recall that first identity, sine square theta can be written as 1 minus cos square theta. 1 minus cos square theta. Okay, now you can apply here here also you should not apply a minus b whole square. Just you factorize it. It means 1 minus cos theta whole square. So it can be written as 1 minus cos theta into 1 minus cos theta. Okay, and here you can apply a square minus b square formula. 1 minus cos square theta means what? It can be written as 1 square minus cos square theta. Now it is looking like a square minus b square, isn't it? So it can be written as a plus b into a minus b. So 1 minus cos theta into 1 minus cos theta divided by a plus b. It means 1 plus cos theta, and a minus b. It means 1 minus cos theta. Okay. Now we can see here in numerator and denominator 1 minus cos theta is common. We can cancel it. So we have 1 minus cos theta by 1 plus cos theta. Here it is equal to RHS. So finally we can write, therefore LHS is equal to RHS. So we have proved. Hence, proved. Okay, I hope you have understood. But still you have any doubt, you can ask me in the comment section below. And if you are new to my channel and if you have missed my previous videos on this chapter, you can go back and check it out. For that, I will keep the video link in the description box below. In the previous videos, I have explained trigonometry introduction, trigonometry table, and I have solved some problems also. So I will put the video link in the description box below. Okay, so if you like my video, please like, share and subscribe. And I will meet you in the next video. Till then, take care and bye bye. And thank you so much for watching.